Okay, 5.2. All right, so now 5.2, we're gonna kind of put everything together and then try to plot the functions, right? So in order to plot a polynomial functions, we need a few factors, right? So the first one is you need to take a look at the end behavior of the graph. So you have an idea what is the shape gonna look like, right? For example, if you look at this curve here, we know that the both ending going upward mean that it has to be an even degree, right? So that's how we know the shape of the graph look like. All right, so step one, determine the end behavior of the function. All right, and then the next one is, if we can find the y-intercept of the functions. And then number three, determine all the real zero of the function and their multiplicity, right? Real zero is same thing as, x intercept, right? And use this information to see whether the graph will cross or touch the x-axis at each intercept, okay? And it's also helpful to have determine the number of turning points on the graph of the function. And then we're going to use those steps to find a complete graph of the functions, all right? So, around the turning point right now, we won't be able to notify exactly where they are. That will be the concept of calculus. So when you go to calculus, there will be section showing you that this is exactly where we will expect the turning point to happen, okay? All right, but now we just kind of make a guess where that's, but the end behavior, the y-intercept, the zero, and then we're gonna cross and touch the x in the intercept, we know for sure, okay? So let me show you step by step example one, and I'll let you guys try out the next example. All right, analyze the graph of polynomial functions. Okay, so I want to look at the degree first, so I know exactly how the end behavior of the function. All right, so I have 2 here, I have a 1 here, I have a 1 here. So total degree will be 2 plus 1 plus 1. So that would be 4. Okay, and then there are no negative in front, so I know it will behave like x to the 4. Okay. All right, number 1, end behavior. Since the total degree equal to 6, and there is no negative side in front, I know f of x will behave similar to y equal x to the 4, okay? So meaning that we are expecting the curve to look something like this. And we're expecting it's gonna look something like that in the end. That is, as x go to negative infinities, y go to positive infinities. And as x go to positive infinities, y also go to positive infinities, okay? Because of x to the 4, right? All right, so I know, you know, could happen something over here, but I know in the long run, I will expect something like this to coming down, right? Could go down up forever, right? Go down and then, but in the end, I will expect something pointing upward directions. So that's the long run behavior. And then let's go ahead, look at step number 2, is try to find the y-intercept. Number 2, the y-intercept. Oh, 4 of it, thank you. All right, so y-intercept, let x equal to 0, so we get f of 0 equal to 0 plus 4 to the second, 0 plus 1, and then 0 minus 2. All right, so we get 16 times 1 times minus 2, we get negative 32. So my y-intercept will be 0, comma, negative 32. All right, so yeah, we know it will have to cross the y-axis at 0 and negative 32. All right, that's step number 2. And then step number 3 is try to find the 0, right? So step number 3, we try to find the 0. Phi of 0. So we need to set f of x equal to 0. All right, so I have 0 equal to x plus 4 squared, x plus 1, and then x minus 2. This saying that x plus 4 squared equal to 0, x plus 1 equal to 0, and then x minus 2 equal to 0. So we get x equal to negative 4, and this one here, multiplicity equal to 2, right? And x equal to negative 1, multiplicity equal to 1, and this one x equal to 2, multiplicity equal to 1. Okay, so because of the multiplicity, so I know exactly how it will behave, right? All right, so I know for sure at x equal to negative 4, f of x will touch the x-axis and behave similar to y equal to x squared, okay, a parabola. Then at x equal negative 1 and positive 2, fx will cross the x-axis and behave similar to y equal to x, right? Which is a straight line at that point. Okay, and then the last step is how many turning points are we expecting? Right? So you look at that, number 4. Degree equal to 4. So we are f of x will have maximum of 3 turning points. Okay, it could be 2, could be 1, but the maximum it can have will be 3, right? So that when you make a sketch, you don't say, oh, let's throw in 5 turning points, right? It's not going to be possible because the turning point have to be less than the total degree that we have expecting. Okay, so let's see what can we put it in. So I know the end behavior, so let's look at the y-intercept. So let's scale a bit a little bit all the way down here. So I'm going to adjust that a little bit. So I'm going to go with 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, expand it out here a little bit. 22, 24, 26, 28, negative 30, negative 32, negative 34. All right. Okay. And over here, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Okay. So we will to fit in the y-intercept. We'll to adjust that. Okay, so let's throw in. So I know the end behavior. I know the y-intercept will be 0 and negative 32. So I have to cross that. And x-intercept will be negative 4, which is right here. And you can see here, it have to touch and turn around, right? So I know for sure it's gonna look something like this, okay? And then at -1, it will cross, so it's gonna look something like this, right? It will cross. And then at +2, it's also cross, so it's gonna look something like this. So those are the 3 x-intercept that we can kind of fit it in together with the y-intercept. And you can see how the graph will look like already, right? Remember, in the ending, it have to point upward both directions. And there we have, okay. So we have one turning point at x equal -4 already. So therefore, if we have something else, it will be the other two, right? So now we can make a a rough sketch of see what's look like, right? So you can see here, it's have to go both directions in that way, right? So it maps the description, right? Okay, it touch and turn around. It could go up here, but it have to turn around again because it have to cross at x equal -1. And also it have to go all the way down until 0 and -32. It have to go through the y-intercept. Let's still go down again, but then it have to turn back, right? Because remember over here, it have to cross the function at x equal to 2. We can have a rough sketch like this. And then it can go up forever because, there's no more x-intercept. Okay, so there we go. Now we can, after we make a rough sketch, now we can put the finalized version of the curve that answer every part of the questions.
Between -4 and -1, how did you know how high that would go?
Yeah, good question, Brenda. Right now, we just have to make an estimation of that.
Assumption.
Right?
Okay.
Yeah, because we don't have the 2 to answer in 141. In 151, you know exactly where it will be. Okay. But that one of the version you can have. But you can see when I grade your exam, I'm gonna see whether you will satisfy all the conditions. For example, I can have another version here, right? I can just go down here and then make sure it's past the y-intercept, and then I can go a bit further, and then I can have that option, Brenda. Okay. So for now, the turning point, we just make an estimation of where it is.
Okay.
But we have to make sure that it satisfies the end behavior. It satisfies the 0 where it touch, it have to touch and turn around. Where it cross, it have to cross. And if we have a y-intercept, then it have to cross the y-intercept around there. Okay. And we cannot draw the graph outside of those requirements that's already expected. Okay, there you go. Those are the requirements. And as you can see my description, you see when x equal to -2, multiplicity is 2, so we know it would touch and also behave like a parabola. So you can see around -4, I will have a parabola shape. And then when you -1 is a multiplicity of 1, so it will behave like y equal to x. So it's a straight line, so you're gonna go straight line through there. And then x equal to 2 is also have power, power of 1, so it will be a straight line go through there. So in order for us to have that requirement filled out, after it crossed the y-intercept, it have to turn around so that you can get back to crossing the x-axis at x equal to 2. And then you can see the long run behavior indicate that it will go up forever in both sides. And that's what we have. Exactly bit, because the requirement said it have to cross the y-intercept at 0 and -32. So you can't really turn around before that. Does that make sense, bit? Yeah. So if I draw another graph, say, okay, I'm gonna go up here, go up there, come back, and then turn around. This will be wrong because it did not cross the y-intercept. All right. Yeah. So we just have to get that. Oh, it was for Natalia. It was 6, but we said that should be 4, Mr. Vo. I fixed that already. Okay. So it should be 4 and not 6. Okay. So it's have to satisfy all that condition that we can have. So you can see here a lot of 5.1 that we learned is an application in 5.2. That's what you see right here. Okay. Okay, does that make sense to everyone? Because on the exam, you will expect to have all of this listed out. And behavior, y-intercept, x-intercept, mean at the 0, and multiplicity of the 0, and what each multiplicity will do to the curve. And then you use all that information and plot the polynomial, okay? Because you can plot the polynomial using a calculator, but that's not gonna count if you don't list out all the steps that you went through. So if you have questions, are you not clear at any step, it is time for you to ask now before the exam. Okay, then now your chance, right? Go ahead and have a practice with the next example. So make sure you follow the same step 1, 2, 3, 4, and behavior, y-intercept, then 0, multiplicity, and then combine all of that and make a sketch. Okay. All right. So let me show you how close we get to the actual graph itself. Right. So what is that? So we get x plus 4 to the second, then x plus 1, and then x minus 2. Right, so that's the one I just plot, and you can see here we very close, right? So estimation here, right? The exact one is it will go all the way to 16, and you can see it's cross 32, and it went all the way to -50. But again, you can see it in the curve, we didn't go all the way there because we don't focus on those turning points that much. We just focus on all that x-intercept, y-intercept, and the ending behavior, right? So when you go 151, they focus on this one, right? They show you exactly how you got that. They show you exactly how you get this on out. But for us, we just see what we can do. Okay, so you should look, your graph should look something like that. Is that what you got? So similar to that bit? All right, thank you, Ringo.
No, my graph looks different, but I can see how I got it wrong, but I got the y-intercept of 0 and 12. So I thought it was supposed to go like that was the
Okay.
max point.
Okay, but be careful, Brenda, right? Remember, you do -0 squared, yes? And then
Yeah.
0 minus 3, then 0 plus 4, yes?
Mm-hmm.
So now you get 0 times -3 times 4. That should be 0. Does that make sense, Brenda?
I did, but I kept the negative sign.
Yeah, because when you have 0, you times everything still 0, yes?
So everything ends up being 0.
Because 0 times 3 is 0, and then 0 times 4 is 0. So that will be 0. That's good.
So then it ends up being -3 times 4.
No, it's still 0. Right? What is -3 times 4? You get -12, yes? And what is 0 times -12, Brenda? Still 0. Does that make sense?
Oh, so you have to keep the 0 there even if it's 0?
Yeah, because it's multiplying, it's not adding. Yes? So when you add or subtract, then you can throw away the 0, but when you multiply, you still have to keep it there.
I see.
Because 0 minus 3 is -3, but 0 times -3 is 0. Yes? So we can't really throw away the 0.
Okay. And then the x plus 4, to find the zeros, it equals -4. And then I said that it's even, so it touches and turns around.
It's not about the 0, Brenda. It's about the power of each factor. Okay?
Oh, so the power is 1, so it's odd.
Yeah.
Okay.
So it's not about the 0 itself. It's about the power of each factor. Okay?
Okay.
Yeah.
Thank you.
All right, Luke got the answer. Jericho got the graph similar to that. How about yourself, Vitz? Yeah, question. You got something similar to that. Barrage got something similar to that. Okay, looking good. Jonathan got something similar to that. Abraham got something. All right, anyone else have trouble with example 2? Because there will be a chance that you will graph something on the exams. Okay. How's that looking now, Brenda?
Yeah, I figured it out. I got it. Thank
All
you.
right, sounds good. Okay, so we have around 25 minutes left, and I don't think I will finish the next section in 25 minutes. I could, but I don't want to rush it because you guys will confuse, and rather take things slow and then have you guys understand it completely than rush into it. Okay, so if you are looking at the exam review number 2, okay, so there are a few questions that relate to the next sections. Okay, so technically you can take off this one, this one, this one, this one. Okay, so don't try to do 25 to 29 because that will something that we won't be able to finish that. Okay, so don't forget, we do have exam next week. And don't forget, turn in your classwork and corresponding homework that we finished. All right, we finished 5.2. Okay. All right, let me go ahead and attend real quick. See anyone here. I have to take a look at that, Luke. I don't know. I have to sit down and do it to see how many, whether it's reasonable. Okay. Nolia. Thank
Here.
you. And Jonathan.
Here.
Adian.
Here.
Thank you. And Vincent. And Brenda is here. Dylan.
Here.
Thank you. And Sumin.
Here.
Thank you. And Dustin.
Here.
Thank you. And Nick. Okay. And Brandon.
Here.
Thank you. And Anthony. Thank you. And Mia. Is Mia here? And Natalia Gomez.
Here.
Thank you. And Gustavo.
Here.
Thank you. And Abraham.
Here.
Thank you. And Tobias.
Here.
Thank you. And Carlos.
Here.
Thank you. And Colvin. Colvin's here. Trin.
Here.
Thank you. And Jericho.
Here.
Thank you. And Karina.